Okay, 29. Old school slot machine. Okay, so old school slot machine, I'm sure you guys have all seen this. It's got this arm on the side and people pull the arm and you've got these 3 windows and there'd be like heaps of cherry. Nice cherry bouquet right here. Whatever a cherry bouquet is. Okay, and if you get 3 cherries, you win, and all this money comes pouring out the bottom or whatever. Okay. Alright, so here's how it works. Each wheel has 20 symbols. Okay, all equal like you show up. The wheels are independent of each other. The middle wheel has 9 cherries, and the left and right have 1 cherry each. So there's enough cherries to go spinning around where you think you're going to win. You think you have a good chance, so people keep putting money in here. Here's a slot where you put your money in, and keep dumping it in, and we're going to win the next time. We're going to win the next time. You know how that works. A. You win the jackpot if all 3 show cherries. What's the probability that you win the jackpot? Okay, so probability of getting a cherry, and a cherry, and a cherry. Well, what's the probability that you get a cherry the first time, times the probability that you get a cherry the second time, probably get a cherry the third time, right? Because they're independent, it doesn't matter what happens the first wheel doesn't affect the second wheel or the third. So probably get cherry the first time is 1 over 20 times 9 over 20 times 1 over 20. Okay, so that's going to be multiply across the top. 9 over 20 times 20 times 20 is going to be 20 to the 3rd power. So let's do 9 divided by 20 to the 3rd power. It is 0.001125 or 0.11%. Okay, so there's your chances of winning. Okay, 0.11%. All right, B. There are 3 ways that the 3 wheels can show 2 cherries. Sometimes 2 cherries win some money, sometimes not. But usually it's just a tease. And 1 symbol other than a cherry. So what's the probability that of each of these ways? So probability of a cherry and a cherry and a not cherry. Probability of a cherry and a not cherry and a cherry. On these ones you really just have to write these out like I'm doing here to help you guide your thinking. Okay, so cherry, cherry, and not cherry. Okay, well, that's the probability of cherry times the probability of cherry times the probability of not cherry. So probably get cherry is 1 out of 20. There's 1 on the first wheel, 9 out of 20 the second wheel, and not a cherry the third wheel. Well, there's 1 cherry on the third wheel, so there's 19 out of 20 on the third wheel that aren't cherries. So we're going to have 9 times 19 on the top, divided by 20 times 20 times 20. And that's going to be 0.0214 or 2.1%. Okay? Now, cherry, no cherry, cherry. So that's probably get a cherry, 1 out of 20. No cherry, well 9 of them are cherries, so 11 out of 20 are not cherries, and 1 out of 20. That's 11 out of 20 to the third, which is 11 divided by 20 to the 3rd power. 0.001375, which is 0.1375 or 0.14% if I round it to 2 decimal places. That's only slightly bigger than 3, but that's because getting a non-cherry in the middle and a cherry in the middle are almost the same. 11 out of 20 for non-cherry and 9 out of 20 for a cherry. And non-cherry, cherry, cherry, non-cherry is 19 out of 20. Cherry is 9 out of 20. Cherry is 1 out of 20. Notice this is the same as this guy up here, right? So that's going to be the same percent, 2.1%. Okay, there you go on that guy. Let's try the next one on the same one here. We got 31. Getting into college. Okay, Ramon has applied to both Princeton and Stanford. He thinks the probability that Princeton will admit him is 0.4, Stanford 0.5, and both is 0.2. Make a Venn diagram. Okay. So we've got this guy here. We've got Princeton and Stanford. Nice schools, right? Okay, let's see. Probably that both is 0.2 or 20%. Princeton is 40%, so that means 20% out here, so that the whole circle has to be 40%, right? And Stanford is 50%, so that's going to make that 30%, so that all of Stanford is 50%, right? 20 plus 30. It's 50%. So now I've got 30, 50, 70% to go in one of these three regions. So that means 30% that he's not going to be in at either one of those schools or get accepted. Okay, so A. Probability that neither admits him. It's going to be 0.3. B. What's the probability that he gets into Stanford but not Princeton? That's just that region right there, isn't it? Probably Stanford and not Princeton. It's 0.3. And C are the independent events. Okay, are Stanford and Princeton independent. Well, how do you determine if they're independent events? Well, one of the ways is to look at the probability of Stanford and the probability of Stanford given Princeton. Okay? If these two are different, then they're not going to be independent events, are they? Okay, so let's see if these are the same. Probability you get into Stanford is 50%. Right? Given that he got into Princeton, okay, what's the probability he gets into Stanford? Well, given he got into Princeton, that's 40%. Of that 40%, how many of them, or what percent is Stanford? 20% of that. Okay? So if I do that, 2 divided by 4 is going to be 0.5. Okay? These two are the same, so it doesn't look like that whether you got into Princeton or not affects whether you got into Stanford. Right? Looks to me like these are going to be independent of each other. Let's try the other way. What's the probability you get into Princeton and the probability you get into Princeton given Stanford? Probability you get into Princeton is 0.4. Probability you get into Princeton given you got into Stanford. Well, the percentage of probability of getting to Stanford is 0.5. And of all those 0.5, the 50% chance of getting to Stanford, 20% of the time you're going to get into Princeton. And 2 over 5 is in fact 40%. So notice, whether you get in, knowing you get into Stanford doesn't affect whether you get into Princeton. And same thing here, because these probabilities are the same here, and these are the same here. So this tells me that these two events are in fact independent of each other. Does that make sense? Alright, there we go. Okay.